Good morning and welcome back to Dr. Logic Awkwardly Does Logic, attempting to start this video for the 6th time because the other ones were too awkward to share with the world. In this video, I'm going to begin defining for you our basic propositional classical modal system, System K, named for Saul Kripke. Now, think back to other proof systems that we've looked at, kind of specific ones rather than kind of general things as we've been talking about in the last couple of videos. Proof systems always consist of two things: axioms and rules of inference. Now, some systems don't actually have any axioms, and they make up for this by having loads and loads of rules of inference. Some have many axioms and very few rules of inference, but those are not generally as useful. The systems that we're going to be looking at are going to be kind of in between. So we will have some axioms, some rules of inference, and then in general, what will happen is we'll keep the rules of inferences fixed, and then we'll construct bigger and bigger systems, more interesting systems that can do interesting things by changing the axiomatic base. This is why it was useful to have all of our discussion about axiomatic bases, inclusion, exclusion, extension, strength, etc. So I'll just give you the axioms in this video because defining the rules will take a little bit of time, and so we'll save that for a separate rule. So this is, as I said, System K, and this is the system that is going to provide the foundation for all of our other systems. Basically, what this one is once you accept that what you are doing is propositional and classical, so you've got the law of excluded middle and the principle of non-contradiction, what are the fewest assumptions about modality that you can make and still have a sensible logical system? That is what this system is going to be. So we're going to have, in terms of axioms, we're going to have two, or rather we're going to have infinitely many plus one, but the infinitely many are going to be all the propositional tautologies. So every propositional tautology is an axiom of System K. So there are infinitely many of these, but any individual well-formed formula, you can determine in a finite fashion whether it is a tautology or not. Therefore, there's a finite mechanism for determining for any propositional formula whether it is an axiom of K or not. So the fact that there's infinitely many of them doesn't matter. In any particular case, we have a finite mechanism that determines, yes, axiom, no, not an axiom. This means that at any point, we can write down any purely propositional formula so long as it is something that is always true. And then we have the kind of modal specific axiom. This is where the modality gets going. This is going to be also called K. Now, if I were doing this in my textbook, we would have a different notation for logical systems and the axioms that generate them. We use different fonts to make a distinction between the set of sentences generated from an axiom or axiomatic basis and the individual axioms. That's really hard to do on a Zoom whiteboard. So I'm not going to be able to make this distinction in the videos, but if you are following along in the textbook, you will see that there is, whether you've got a serifed K or a sans serif K, this has a different semantic meaning. Anyway, our axiom K is this: if it is necessary that P implies Q, then necessary P implies necessarily Q. That is our foundational axiom and provides the basis for every other modal system that we are going to look at. Next, I will give you in a separate video the 3 rules of inference, and then we'll start talking about putting all of these things together. Why this axiom? Why these rules? What can we prove from them? What are the interesting theorems? Are there anything that we can, any shortcuts that we can add to our proof system? And I will also give you the definition of normal. Until then, take care, enjoy, see you later.